Hi, everyone. Thank you for joining me today. I'm Denis. I will be talking about zero downtime deployment for web applications. Its principle is basically what it says. Zero downtime deployment means there is no downtime during the deployment. So there are no interruptions of user flow, no errors, nothing. It just works, seamlessly upgrading to the next application version. Why? Because we want to avoid user frustration and because we want to deploy as frequently as we want without interrupting user flow. And it enables faster iteration speed. How much faster? Maybe some of you have seen this Amazon presentation on one of the developer conferences. They're deploying every 11 seconds on average. And as you can imagine, if they had any downtime during the deployment, it would be impossible. So large companies have been doing this for many years. I'm not sure if anyone has seen this presentation. Do you know which year it was? It was 2011. So 15 years ago, it was kind of like magic. Like, wow, these guys are doing state-of-the-art technology. But fortunately, these days, technology has advanced. It's more readily available. And now everyone can do it. You don't have to be Amazon to deploy as frequently as you want. But unfortunately, not my bank. It regularly sends me emails about scheduled downtime. And these guys probably haven't learned it yet. But we will learn it today. So the very first thing that I would like to do before working on zero downtime deployment is monitoring. Basically, what I want is a quick feedback loop. We did a deployment, and what happened? Was it clean, or were there any problems? This is a screenshot from our team chat. You can see, in this case, the deployment wasn't clean. We deployed it and saw a bunch of errors. MySQL has gone away, and that wasn't clean. This is the feedback loop that I'd like to have, just to understand if we're doing a good job with the deployments. A lot of things can be monitored in real production environments. But for this particular task, we will need to crash reports from the application and like classic uptime monitoring. These two work in combination. There are plenty of tools that are doing this. If the application instance is up and running, but there is some kind of a problem, we will get a crash report. And if it's not running at all, there will be no crash reports, but uptime monitoring will tell us, like, hey, your website is down. So this is like prerequisites, what I'd like to have before working on zero downtime deployment. Now, what can go wrong? Everything. Each component of the modern web application, the front end, the back end, and the database may cause issues during the deployment. Good news is that it's all pretty much manageable. And now we can go through them one by one, learning about problems that may happen and how to deal with them. Starting with the backend. Those of you who worked with PHP and Apache know that it does not require server restart. You just update the files and it works. And it's cool, right? So simple. The problem, though, is it's not very efficient. If for every request it reads new files from disks, it's just slow, right? So most application servers cache the application code in memory. And so to force them to pick up the new version, we need a server restart. And this is where downtime could happen, right? When we restart the server, there could be a short blip of downtime. Some application servers support Graceful restart, namely UWSGI, Nginx unit, PHP, FPM, etc. Basically, we can send a special command to the application server and they will do their best to reload the application code without losing any HTTP requests. But arguably the most common way of dealing with this is with a load balancer. So here we have multiple application instances behind the load balancer, and we just replace them one by one, excluding them from the balancer, upgrading, and putting back. For this thing to work, we need some kind of a container orchestration system. It's also possible to do it on server level, but these days, more commonly, it's using tools like Kubernetes and similar. And some script that we will run on our CI/CD system that will instruct the container orchestration system to do its job, to load the new version of the code. Let's talk about deployment strategies. One of the most common and I would say simple one is the blue-green deployment. Let's say we have a current application version that is running in production. Let's call it blue. And we have a new version that we would like to deploy. Let's call it green. So what it does, it prepares this new version on a separate server instances, checks that it's ready, that it's up. And once it's ready, it just switches traffic on the load balancer, and almost instantly, new version is up and running without any downtime. The benefits, it's the fastest, I would say. We can prepare this new environment, all of its application instances in parallel, and the switch is almost instant. Also, we can have an instant rollback if needed. I would probably not use it if I can. First of all, it's not always possible due to various instances, but that's probably a topic for another talk. But anyway, if you want, instant rollback is available. The downside, though, that it requires double the server capacity because we need that where to launch these new instances while the previous version is running, right? So to solve this problem, people invented rolling updates, which does not try to replace everything at once, but does it gradually, turning instances off the cluster, upgrading them, and putting back. It's slower, obviously, but it doesn't require double the server capacity, which can be quite expensive for large projects. For rolling update, we typically configure two parameters, minimum and maximum capacity. So let's say we have 5 application instances behind our load balancer, and we count that as 100%. If we tell the orchestrator system, never fall below 80%, and you are allowed to grow up to 120%, that would mean that it can shut down one running instance, and it also is allowed to launch an extra one. So it will update 2 instances at a time, and it will affect the deployment speed. The larger the window is, the more instances we can launch in parallel, and the faster upgrade process will go. But we need to be careful with this minimum threshold not to fall too low. Otherwise, there will be a performance degradation, right, or even a downtime. And we should be careful not going too high, because it will require additional capacity. For example, if we say these parameters at 100% and 200%, it would be basically similar to blue-green deployment, right? Prepare everything at once and launch it all at once. In this case, just use blue-green. But that's expensive, so this is why we have this configuration. So to summarize, it requires less resources. Speed may vary. Instant rollback is not available. I personally do not regret, but anyway. Now let's talk about updating the database. Some web frameworks have database migrations built in, like Django, Rails, and Laravel. There are standalone frameworks for database migrations. Basically, what all of them have in common is that they produce some database migration scripts. They can be either in SQL or in the programming language of your framework. But they do the same thing. They basically bring the database from its previous state to its new state, updating the schema and data if necessary. They can also do a reverse process. They may include like a rollback section. If you need to downgrade, it can also be a part of the script. When do we run these scripts? We need to run them before doing anything else. If you launch a new application version that requires database to be updated, it needs to be updated first, right? If it's not updated, the new version will not work. So updating the database is the very first thing that we do. How we do this? We need to launch the DB upgrade script once and exactly once. And if it fails, just cancel everything and don't do any further deployment. And if it succeeds, update the app. Why I'm talking about this? Because I have seen that many developers think that it might be a good idea to include the database migration script right in the application start script. So we run the migrations and immediately start the app, right? That's simple. The downside, though, that it can be dangerous. First of all, imagine that we are running multiple application instances behind the balancer, and we are trying to update like all of them. What will happen is that multiple new instances will be launched in parallel, and all of them will try to migrate the database. Even if your database migration framework correctly handles these parallel attempts to run the migration, if it's not, like, that can be a huge problem. Fortunately, it does. Even if it does, the migration might fail due to various reasons. For example, it can launch a heavy database update, which just overloads the database server and fails with a timeout. If you run it once, there will be, well, a blip of downtime. If you run it like this, you multiply the blast radius. Multiple application instances will try to do it like again and again and again, and instead of a small downtime, you will have a huge downtime. So don't do this. Now, what we need to think about when upgrading the database is backward compatibility. What do I mean by that? Imagine we have a current application version that is running in production. Let's call it V1. And we have a second version that requires some changes in the database to run. And we run the database migration script. It brings the database to the new state, version 2. And remember, the deployment process isn't instant. So there will be a time when the previous application version is still running, but the database is already upgraded. And if they are not compatible, there will be a problem, right? So how do we avoid this? Let's talk about a concrete example. Let's say we want to add user avatars feature into our application. Like, for example, 12 years ago, GitHub introduced these fancy identicons, how they call it. Let's say we want the same. We want all users to have randomly generated avatars, and they can upload their own if they want. To do this, we want to introduce a new column in our database in the users table called avatar. What do you think? Is this operation backward compatible? It's not. It's not, because the column is not nullable. So what will happen is that the previous application version that is still running, it will try to insert new records without this column, and it will fail. So effectively, registrations will be broken, which is pretty bad in my opinion, right? So how to avoid this? We need to split our deployment into two phases. Just not try to deploy everything at once. In the first phase, the preparation phase, we add the new column as nullable. It will not cause any problems because it allows empty values. So this is fine. And also, we will educate the application about that new column. We will teach it to generate new values for it. So it will start writing values when adding data. And we just deploy it. At this phase, at phase 1, there are no visible changes for the user. It's just the preparation that we do under the hood for the phase 2 to be successful. And the phase 2 actually deploys all of this functionality. It generates random avatars for all users, like filling all empty values, makes this column not nullable, and adds all of the features related to this functionality. After phase 2, like, the feature is finally deployed. Okay? Another example. How do we remove this? Let's say this feature was unpopular, I don't know, for whatever reason. It didn't work out. So we want to revert everything and just remove the column that is no longer needed. So how we do this? Again, if we just simply remove it, it will be broken, right? The application expects it to be there, but it's not there. So again, we are splitting our deployment into two phases. In phase 1, we make this column nullable, and we remove all mentions of it from the code, so that application no longer reads or writes, or just it's not aware that this column exists. And we deploy it. After it's successful, we can just drop the avatar column in the next phase, and we're good. I wrote a blog post that describes all of this in the details. There are more complex examples. For example, renaming a column might require up to 4 phases during the deployment. If you're interested, I'll mention the link at the end of this talk. Anyway, to summarize, to maintain the DB backward compatibility, we need to, first of all, be aware that it might cause problems. Split our migrations, if necessary, into multiple phases. And this is something that developers must learn. Unfortunately, this cannot be fully automated. So this is just a skill that we need to acquire. The good news, though, is that you can write tests for it. We did it on some of our projects, and it was a success, and it saved us a few cases of potential downtime. The idea is pretty simple. Basically, we take the previous version of the application that is currently running in production. We take it from Git history. We prepare the test database for it like usual. Then we apply the migrations from the new version and run the tests of that previous version. If they pass, we think we are good, right? If they fail, there is a problem. All right. Another.
Do you mean automated test or manual test for the migration, database migrations?
Excuse me, say it again.
Automated test or manual test?
Yes, I mean automated tests.
Automated test.
Yes. So we have it in the pipeline of some of our projects, and it really works. It's especially useful for newcomers because, as I mentioned, this is a skill that developers need to learn. And when new people join the team, we tell them, here is a blog post, please read it, etc. But reading the blog post and actually doing this, there is a gap. So.
And do you keep the tests also after the migration is in production, or you remove the tests after?
These are not special tests. These are just regular tests of the application. It's just about the way how we launch them. We launch them against a newer version of the database. And if they pass, they're good, right? OK, so heavy operations. This is different, and this one is database specific. If the previous topic, like backward compatibility, applies to any relational database, right? For this one, you will need to learn how your database works. If you are using Postgres, learn how Postgres does DDL operations, which logs does it acquire at which stage, etc. If you are using MySQL, same thing. Learn how MySQL works. You can probably benefit from upgrading your database. If you are running an older version, you probably do not have some of the new features. Databases are improving all the time, so the latest version could make your life easier. But even with the best knowledge of your database engine, with all of the clever tricks, there are just some situations when it's impossible to do a database migration in one step during the deployment. If you're trying to update a huge table with millions of rows, I don't know, with terabytes of data, it's just not possible, right? So what you need to do in this case, embrace slow running migrations. Do not try to do it all at once. These migrations are different. They are launched in the background in parallel with your application running in production. And they just slowly convert the data from the previous format to the new format. Depending on the amount of data, it may take days or weeks or even months in some extreme examples. Fortunately, not all projects have so much data. So if you do, you already know. If you don't, basically, you can forget about it for some time. All right, and finally, updating the front end, which surprisingly can also cause problems. The first and very obvious is cached version of static files like JavaScript and style sheets and images. Everyone is familiar with it, and basically how to deal with it is also well known. Some people use file hash in the URL, others add CI build number in the URL. Basically, the idea is change the URL, and once it's changed, you will bypass the browser cache, the CDN cache, and users will get the new version. Unfortunately, we can also run into backward compatibility problem between the front end and the back end. Imagine we have version 1 of our application currently running in production. Everything is fine. We are launching the new version that requires updates in both the front end and the back end. And after the deployment is done, the previous backend version is gone, right? We only have the new version. But the previous version of the front end may still exist in users' browsers. They may have the tab open, And some people do not close browser tabs for days or even weeks. They go crazy with hundreds of tabs open. And when they activate that tab and it tries to communicate with the newer backend, we may run into a problem. It's incompatible. So what do we do? First of all, we need to detect such a situation. We need to somehow learn, the front end must somehow learn that it's outdated. For this to happen, it must know its own version first. It should be aware, like, I'm version 1. And it should also learn about the backend version it's talking to. For example, with every API response, the backend can return its version, like in HTTP headers. And by comparing its own version with the backend version, front end might learn that, well, it seems I'm outdated. Okay? So once we learn that, what do? We should probably trigger a page refresh, right? A naive approach would be just do it, right? We know that front-end version is outdated. Just refresh everything. It will work, but it may cause user frustration. Because if we are doing in a bad moment, it will cause really bad user experience. Imagine if we have some search functionality in our app. Users just start typing. The front end sends request to the backend, learns that it's outdated, and just refreshes the whole thing. Looks pretty bad. Also, users are scrolling. The app tries to load additional data, learns that it's outdated, and refreshes the whole thing, like losing the scroll position and everything. So pretty bad. How we can do better? We can try graceful front-end reload. What that means is that we do not try to refresh immediately. We make a bet that maybe it may work for some time. If versions do not match, it does not necessarily mean that there is incompatibility. There could be just internal changes on the backend, right? And even if there is incompatibility, it's not necessarily in the same view that user is looking into. Maybe it's some other part of the application. So maybe we let it run for some time and wait for a good moment to do the refresh. A good moment might be when users click a navigation link. In a single page application, it's normally done without full page reload. But if we know that the front end is outdated, that's a perfect moment to do the refresh. Because users, anyway, they expect to go to a different location, so we can just do a classic handling of a link with a full page reload. If we are not lucky and something bad happened, there was incompatibility and users ran into a problem, we can add a reload in our error handling. So basically, if there was an error, and at the same time we know that the front end is outdated, we can guess, well, maybe that's the reason. They ran into a problem because our front end is outdated, and then show users a prompt and reload the page. Okay? Unfortunately, problems with the front end doesn't end there. Yes?
A couple of questions about this. Usually SPAs assume that the link is not going to be soft links, so they keep the application state in memory, like the state of the JavaScript objects you have. It's essentially the state of the application. So if you now consider a link a hard link, you're going to basically, if your app is naive approach, you're going to lose the entire application state. So it means that on the front end, you also need to do some work to persist our state of application. And secondly, the other question I had was about mobile application, where you can really control when people are going to update the application. It looks to me like the only sensible thing you can do at that point is say, look, you have to update the application, go on the App Store and download the new version. So if this has some way of some applicability to mobile application.
Mm-hmm. Yeah. So 2 questions. First of all, will we lose the front-end state when we reload the page? I would say it depends on how our app is built. If we have some hidden state that it's not in the URL, we will lose it. If we do not take any additional measures, like for example, we can save it in local storage. If it's important, for example, users were editing something, they have unsaved change, we can use browser storage to store that. And basically, this whole thing is about how we design our front-end application. With front-end, we cannot just handle it with all these CI scripts and everything. We need to think about it when building our application, and if it's built properly, basically it should work. As for mobile, it's a different story. We do not control how users update their mobile apps, and sometimes they do not update them at all. We publish our new version in the App Store. Some users update it and some doesn't, and they may run the old version for years. We can probably prompt them to update. But if we are doing this too often, that would be annoying. So if it's so old that we can no longer afford to maintain it, then yes, prompt that users to update. And so no magic here. All right, so the weird one, forward compatibility. It may happen if we are running rolling updates. Just recently, we were talking about backward compatibility. Now it's forward. As you remember, during the rolling update, there is a period when new backend version and old backend version coexist. They are both running at the same time. And it could happen that some users have been served the new version of the front end, but when it tries to communicate with the backend, it hits the older version of the backend. And it will be a problem, right? So what can we do? First of all, not use rolling updates. If you can afford it, you can just write it down as another benefit for blue-green deployments, because they simply do not allow for such a situation. There is no moment when 2 versions coexist in time. But if you cannot afford it, maybe the project is so large, what you can do? You can balance API requests on the backend. So the client, the browser, will need to tell its version when sending an API request. And the load balancer, depending on this version, should try to serve it from the previous application version if it's still running. Or if it's not, redirect to the new version. It adds extra complexity, but you may have to deal with that. A simple way of doing this is using sticky sessions. Many load balancers support this. It basically sets a special cookie using which load balancer can link user's device back to the original node from which it was served for the first time, and redirect all subsequent requests to the same node. So it solves the problem, but brings another one. Namely, uneven load distribution on the backend. Because all requests will be linked to their original nodes, a user who is sending a lot of requests will send all of them to the same node, and it will become a hot node. and they might have a bad experience, like degraded performance, even if we have a lot of server capacity. Like all other nodes are idle, but all requests are just routed to a single node, and it's bad. Finally, we can try a simpler approach, just modify the front-end code in such a way that it looks for such situations when there is a response from an older version. And if there was an error, just wait and retry after a certain time, assuming that maybe the deploy will be finished and finally we will hit a new version. So to summarize, what can cause downtime during the deployment? First of all, the backend may be simply not running. If we do a hard server restart, there will be a blip of downtime. We can run into incompatibility either between our backend and the database, or between the frontend and the backend. Frontend may be cached, but that's the simple one. And the database might be overloaded with heavy requests if you are trying to do too much in one step. The good news is that it may look scary, but it's actually pretty much manageable. And for most of these problems, you can solve them once and for good. You can automate backend updates via your application infrastructure and clever CI/CD scripts. You can deal with front-end updates by properly architecturing your front-end code. But the database migrations is something that you will have to learn. You can automate parts of it, namely how you run the migration script, maybe implement backward compatibility tests, but still, this is something that the team might have to learn. And I also wrote another blog post that just summarizes all of this. You can find all my posts at my personal website. Please feel free to connect, my LinkedIn and Twitter, and I'll be happy to answer any questions about your project. And I'm happy to answer any questions right now if you have. Yes?
What's your experience with the Graceful shutdown, explicitly in application with long benches?
Yeah, that's a good question. So Graceful shutdown, it can be applied to shutdown of web workers. So we do not want to interrupt, in the middle of serving a request. So usually they have some timeout when they still trying, to process these requests, not accepting any new ones, and shutting down after those are handled. As for very long running tasks, like minutes or hours, these are usually background tasks, like cron jobs or frameworks like Celery or Sidekick and Ruby. This is a bit a different story. First, they do not affect the user experience in the same way that the web does. So if web is like shut down unexpectedly, users will see an error, right? If the background task was shut down, probably something will be delayed. And that's usually less of a problem. If we handle restarts properly, if our background tasks are idempotent, they can, can be shut down and then restarted again without, causing any issues. That's fine. If we have very long-running tasks, like they take hours, right? And we are doing our deployments frequently, like Amazon, every 11 seconds. There could be a situation then, if you do not take any additional measures, then the background task simply has no chance to finish. it starts working. After a minute or two, it's shut down. And it takes like an hour, let's say an hour to complete. It starts working again, and it's shut down again after a few minutes. So if you do not take any additional measures, it will simply never complete, right? That's a problem. So what do? We just try not to, let me say it like this. We try to write our long-running tasks so that they can save intermediate results and resume from the same point, basically. So if you launched a long task that takes 1 hour to complete, it was shut down after 10 minutes. It produced 10 minutes equivalent of work, saved it, and the next time we launch it, it will start from where it's finished. So it will only need 50 minutes to complete, and it will eventually complete. Does that answer your question? Sure. Any more questions? Yes?
For example, we talk about CSD, and maybe in my mind, chart-based development. We usually basically do migration by not maybe renaming the column, but just creating a new one. And if it's needed, we drop the old column when the old is merged by the old name.
Mm-hmm.
Is that something that usually in a big environment works, or is something like kind of I would say naive, but I mean, do you have experience about something like this, like just creating other columns instead of dropping and things like that?
So the question is how to rename a column, right?
Yes and no. I mean, from my experience, I usually try never not to drop anything into it because it would use some backwards completely wrong. So I know what's your point of view on that.
Surprisingly, dropping things is simpler than adding new ones. And having outdated columns that are no longer used, it may cause problems actually, because basically the database becomes slower. You have the additional data that you don't use, so all the queries will be slightly slower. Also, if you have columns that require a value, once again, your application needs to be aware of these columns and write the data that you actually don't use. So I personally, I'm not a fan of leaving those, columns that I no longer need. If we ever will need to get some data for whatever reason, backups exist, and we can pull it from there. As for renaming the column, you mentioned basically the same approach that most people use, like just create another one. It may also include converting the data type. For example, you may have a string value. Now you want a foreign key. You cannot simply, convert one to another. So basically, you add another column, do the data migration. Once it's done, we can drop the one that is no longer needed. Sure. Yes.
You spoke about the blue and green deployment.
Uh-huh.
So, honestly, I prefer something like a Canary or a mesh. So, why, your opinion, it's better blue and green?
Yes, Canary deployment is that I didn't mention because I just didn't want to complicate the thing even more. It's a very good practice. Not everyone uses it, but large companies do. Like, for example, like Google, they would launch the new version, for example, for 1% of the audience, see the metrics. If it's good, deploy it to 10%, still good, deploy it to everyone, right? That's the Canary deployment. I'm not sure if it can be fully automated because some of these metrics can be, I don't know, business metrics. Like, for example, the number of orders in our store dropped significantly.
But you can set, you can set the percentage of users that will go to the new version of or you can set the parameters as, for example, a request from this kind of IP will go to the new version. So in this way, you will have all your customers in the old version. Your testing team, maybe in a VPN, so you're sure that they have the same IP, goes to the new version. So
this approach is definitely safer because even if we have a problem, the impact will be limited to just a portion of our audience, not everyone. But even Google, as you might remember, recently have a huge outage that brought half of the internet down. Where was the Canary deployment, I would ask? Any more questions? Thank you.